Can you see the screen now?
Yes, ma'am, we can.
Okay. If you have any questions, you'll let me know. Okay, let me just remove this. We are here. So, do you guys have a clue on what matrices are? Or it's the first time? Guys? Hello. Is it your first time to hear the
Ma'am,
word matrices?
no, it's not the first time, ma'am.
Okay, so then we can just go through the definitions fast, name. So they say the definition of a matrix. A matrix can be regarded as a rectangular array of numbers of elements. For example, you're given this, right? These numbers inside are then called elements. Now the dimension of this matrix will be what? Will be a 3x4 because it has 3 rows and 4 columns. It has 1, 2, and 3 rows. And then this is how you look at your columns: 1, 2, 3, and 4 columns. And as it's demonstrated here, where it shows that the horizontal lines are called rows, meaning that if you move like this, you are moving in terms of rows, and the vertical lines are called columns. The number of rows is always given first, and then the number of columns is given second. So as you say, if you're looking at the, let's say, matrix A, the dimension 3x4 means that this is the number of rows and this is the number of columns that a matrix A has. Now they say, since matrix has 3 rows and 3 columns, we say that the order of this matrix is 3x4, meaning that the order of this matrix over here, it's a 3x4 matrix. The elements of a matrix can assume any form. Therefore, it means they can be real numbers, or they can be complex numbers, or even algebraic expression. For example, meaning that you can have a 2, you can have a square root of I, you can even have x plus y, meaning that you can have such expressions within the matrix, basically. It says 0 minus 4. So you can have algebraic expressions, you can have complex numbers, and you can have real numbers. Now, here's an example. In this example, they say, okay, fine, we have this information over here, and we want to represent it in terms of a matrix, meaning that matrices are useful for also representing given information into a summarized form. So in this case, they say that the following information about 4 persons was obtained in survey, meaning that there's a person X, person Y, person Z, and person T. Now, these persons, they went and determined their age and their weight, their eye, the color of their eye, and whether they are trained or not. Now, they also then went and gave codes to the color of the eyes. So they say that if your eyes are blue, they give 1. If your eyes are green, they'll give 2. And if your eyes are brown, they'll give 3. Now they say, suppose the training code, they went and also gave the training a code, because now these are words, they are not values, these are words. So then they went and gave them a training code where they say, if you are trained, you'll be labeled as 1. If you are not trained, you'll be labeled as what? As 0. So now in this case, we are asked to then put this whole information in a form of a matrix. So how do we do that? So we go and then write the rectangular array, right? So when you write a rectangular array, you then say, okay, fine. The vertical part, right? The vertical part will be the person. So meaning this part here, let me choose a different color. This part here will be person X, and then you have information for person X. This will be person Y, information for person Y. This will be information for person Z, and this information for person T. Now, let's go and put the vertical part. So those were the horizontal part. So now the vertical part, what do we put? We know we are given the weight, so the weight, we'll put it here. We are given, we are given the age. So age, let's say A for age, we put it there. And then W for weight, we are given the weight. We are also given the eye color. So let's say EC for eye color. And we are also given whether this person is trained or not trained. Right? Now we then go and substitute. We know that for X, the what's this? The age will be what? 33. The weight will be 52. The person has blue eyes, meaning that we go to the coding. Blue is for 1, and then the person is trained, so meaning that this will be 1 as well. We do the same for Y, which is then 23, 58. Person has blue eye, we know that's 1, and then the person is untrained and coded at 0. We go for person Z, we know this person is 28 years old. This person weighs 60 kilograms. They have green eyes. We go for coding. Green eyes is 2, so this will be 2. They are trained, so meaning this will be 1. And then we go to person T. Person T is 30 years old. They weigh 59 kilograms. Their eyes are brown, so coding for brown is 3. And they are trained, so meaning that it's 1. So then this helps to actually represent information into a form of a matrix. Are we all clear, or is there a question?
Clear.
Thank you.
Clear, ma'am.
So then the information can be reproduced in a matrix form as a 4x4 matrix. Now they're saying each row in the matrix represents one of the person in the data, as we said, meaning that this is person X, person Y, person Z, person T. For example, the information for person Z who is mentioned in the third row, meaning that the third row, which is this, as we said, person Z. Each column contains one of the variables which were determined for each person. Column here, with this we said it's weight, this we said it's age, this we said it's eye type, and this we said what? It's actually whether the person is trained or not. For example, the second variable is mass in the second column. Now they say matrices are very useful because they enable us to consider an arrangement of a large number of elements as a single symbol. And then to perform calculation with these symbols, it is very compact form. This mathematical shortening is very powerful and effective for solving various practical problems. If the number of observation and the number of variables increase, the matrices become more and more tedious to manipulate manually. In practice, computer packages are generally used. However, it is necessary for the intelligent user to understand the methods and theory behind the computer solutions. Does it make sense or not? This whole statement over here. Make sense or not? Guys, does it make sense why we are using matrices? Because then you have to understand why you're using matrices. Does it make sense? Okay, I'll assume that quiet means make sense, so therefore I'll not explain. So now they say, formally, a matrix can be defined in the following manner. On this block, they actually define a matrix. Now they say a matrix has m rows and n columns. So meaning that this matrix A here, it's an m by n, right? And then A11 represents an element in the first row and the first column. A22 represents an element in the second row and second column, meaning that AMN represents an element in the mth row and second column. Okay, so now they're saying that Aij is any real or complex number, meaning that Aij, the elements can either be real or they can either be complex number. Are we together, yes or no?
Yes, ma'am.
We go together, ma'am.
So now they say the element is a typical element of a matrix A. The first subscript I refers to the row. As we said, this I here, it's ij, so we have ith row and jth column. Now, two matrices are equal if two matrices are equal if they equal one another element for element. That is, meaning that you can, if you have a matrix A, let's say you have A11, A12, and A21 and A22. You can say these two matrices are the same. Let's say B11, B12, B22, B21 and B22. You say these matrices are equal if this is exactly the same as this is exactly the same as that, this is exactly the same as that, and this is exactly the same as that. Then you say two matrices, whether 2, 3, or 4 matrices are equal if all of the corresponding elements are equal. Are we together, yes or no? Or did I miss somewhere?
We are together, ma'am.
Thank you. Now they say that if you have B, right? This is a matrix B, and they want you to find B13 and B22. So meaning that they want you to find an element in the first row, third column. So let's see. So B13 is an element in the first row, third column. So where's the first row? The first row is this one. And the third column is this one. So meaning that 3 is what? B13. And then B22, they want you to go and find the second, an element in the second row, second column. So second row, second column. So meaning that's the 2. So this is equals to 2. Did I lose anyone? Can I continue?
Yes, ma'am, you can.
Continue, ma'am.
Thank you. Let me see if I'm recording. Okay, yes, it's recording. So that's what we found. Now you have the activity that you have to go and do there in your study guide. Now, let's look at the classification of matrices. So matrices can be classified according to the specific formats in which they are expressed. In order to classify a matrix, we must take note of the following types of matrices that occur. So a row matrix, right? A set of n elements arranged in a row is a row matrix of order 1 by n and is called a row matrix or a row vector. Are we all okay on what a row matrix is and a row vector is?
Yes, ma'am.
Let me just explain this one. So now they're saying that you have, let's say A is equals to, you have 1, 2, 3, 4. Now this is called a row matrix because why? It has one row and how many columns? 1, 2, 3, 4, 4 columns, right? Or it's called a row vector. Oh, they gave an example. Now, then we have a column vector. A set of m elements arranged in a column is a matrix of order m times n and it's called a column vector. And this is an example of a column vector. Are we all together there?
Yes, ma'am.
Now they say a 1 by 1 matrix, a matrix with only one row and one column is called a scalar and it's nothing more than just an ordinary number. Yes or no? Together.
Together.
Thank you. A matrix is called a square matrix if the number of rows equals to the number of columns, meaning that if you have 2 by 2 is a square matrix because the number of rows is equals to the number of columns. Now this one is how many rows? 1, 2, 3. And how many columns? 1, 2, 3. So B is a 3 by 3 matrix and it's called a square matrix because the row is equals to the column. Together.
Yes, ma'am.
Yes, ma'am.
Thank you. a diagonal matrix, a square matrix. Now, they're saying a diagonal matrix is a square matrix, meaning that the number of rows is equal to the number of columns. If you're going to talk about a diagonal matrix, it means that the number of rows is equal to the number of columns. So they're saying that it is a square matrix in which all the elements are 0, except those on the diagonal. That's why it's called the diagonal matrix. So all these elements on the main diagonal are non-zero. And then all of the others are 0. That's why it's called the diagonal matrix. Yes? Can I move on?
Yes, ma'am.
Yes, ma'am.
Now the null matrix, a null matrix also called the zero matrix. It's a matrix in which all the elements are 0. And it's called the null matrix. It doesn't necessarily have to be a square matrix, but it can be any type of, it can be a matrix with any form of dimension. Therefore, it's called a null matrix or a zero matrix, as long as all the elements, this is also a zero matrix, where you have 0, 0, 0, 0, 0, 0, where this is not a square matrix. So that's also a null matrix. I hope we are together there.
Yes, ma'am.
Now in identity matrix, a matrix, what's this? A square matrix with 1 on the diagonal and 0 everywhere else is called a identity matrix, meaning that you cannot have an identity matrix if you do not have a square matrix, where the number of rows is equal to the number of columns. And the identity matrix is represented by the notation like this. So if they say I is equal to 4, then they mean a 4 by 4 matrix. So this is a 4 by 4 identity matrix, and this is a 3 by 3 identity matrix. Now, let's go to symmetric matrix. A square matrix, do you see that every time with identity matrix, it has to be square? With symmetric matrix, it also has to be a square matrix. Now, they're saying that a square matrix is called symmetric if the ith row is equal to the ith column of the row and columns. Is that clear or not?
Not clear, ma'am.
Not clear.
Yes, ma'am.
Okay, so they're saying that a square matrix, meaning that a 2 by 2, 3 by 3, or 4 by 4 is a symmetric matrix if row 1 is equal to if row 1 is equal to column 1. I mean, not equal, but the same as column 1. If row 2 is the same as column 2. If row 3 is the same as column 3. For example, look at this one. Row 1, if we put it in column 1, do you see it's the same, exactly the same as column 1?
Yes, ma'am. Okay.
Row 2 is exactly the same as column 2.
Yes, ma'am.
And then row 3, where's row 3? Is this one. Is exactly the same as column 3 because this is 594, 594. So
Okay,
then we
ma'am.
say that matrix is a square matrix. Okay? Are we together?
Yes, ma'am.
Thank you. Now let's go to transpose of a matrix. The transpose of a matrix is obtained by switching the rows and the columns of a matrix. Are we together there? So
Yes,
what
ma'am.
they mean is we have this matrix X. Yes, is someone calling me? We have this matrix X, right? Now, with this matrix, if they say find the transpose of X, that is X to the power of T, so they mean that the rows becomes the columns and the columns becomes the row. So you go and take the first row and write it here. That will be 2, 4, 7. Take the second one. This will be 6, 8, 9. Take this one. This will be 1, 0, 3. Take this one. This will be 9, 7, 8. Therefore, you have, by doing this, you have found the transpose of what? Of X, which is given there. And it's denoted by X to the power of T. So this means it's the transpose of the matrix X. I didn't lose anyone there, right?
Yes, ma'am.
Together.
Mm.
Now, a lower triangle matrix also has to be, when you talk also, okay, so when you're going to talk about lower triangle matrix and the upper triangle, it also has to be a square matrix. So what is a lower triangle matrix? Now they say a square matrix of which all the elements above the diagonal. Remember the diagonal, this one. This is the diagonal. If all the elements above the diagonal are equals to 0, then this is called the lower triangle matrix. Does it make sense now? Yes or no on this one?
Yes,
It's
ma'am.
lower triangle. There we go. Okay. Now it means the upper triangle will be the opposite. So they say a square matrix in which all the elements below the diagonal are equals to 0 is called the upper triangle. So then this is the main diagonal and the elements are up here in the upper part of this triangle. So this is called the upper triangle. Are we all together?
Yes,
Yes,
ma'am.
ma'am.
Now let's look at number B. That one is. Let's look at number 8. Number 1 is a big matrix. Let's look at the B. It says classify each of the matrices and give the transpose of each. What can you say about matrix A? When you classify it, what can you say about matrix A? Guys, we're supposed to classify this matrix. What can you say about matrix A? Hmm? Hello? Are you guys here? What can we say about matrix A?
Can I
Guys,
try?
yes, please.
What I'm noticing is it's got 4 rows and 5 columns. So
Oh,
it's
sorry. Not matrix A, matrix B.
Oh, okay. So it's a square matrix.
Well done. The other thing is it only a square matrix?
No, it says got equal that thing of like row 1 is equal to the column 1. What did you say again?
Symmetric.
Yes.
Well done. So that's a symmetric matrix, right? So meaning that it has row 1. The row 1 is exactly the same as column 1. So meaning that it's a symmetric matrix, and then it's a square matrix because the number of rows are exactly the same as the number of columns. Are we all together? Then how do we find the transpose? Where am I going now? How do we find the transpose? So
the column becomes the row and the row becomes the column.
done. So B transpose is equals to, we take this row, we write it as 4, 3, 2. We take this one, we write it as 3, 2, 4. We take this one, we write it as 2, 5, 6. And therefore, if we look at the matrix, it's exactly the same as B. No, it's not. Let's see. 4, 3, 2.
3 to 5.
5.
3 to 5, ma'am.
Yes, 3 to 5. Yes, it's exactly the same. So now since B transpose is the same as B, therefore we say that this is a symmetric matrix. Now, how did you classify the matrix? You say this matrix is a symmetric matrix, number 1. Number 2, it's a square matrix. And number 3, we're able to find the transpose of that matrix. Am I losing someone here? Yes or no?
No, ma'am, we're with you.
So all of these, so these are your activities post-test. So you need to go do all those questions. And if you have any question, you can send me an email and I'll help you. Now let's go to linear algebra matrix multiplication. The reason why you have to learn these matrices is because sometimes when you collect data, let's say you are collecting African data on people with TB and let's say TB, HIV, and other diseases, right? Now, if you collect such data, it will come in a form of an Excel, maybe, for example, where you have a lot, millions and millions of people, and then you can arrange them in a form of, you can arrange them using the Excel. So if you want to remove people from the Excel or remove a person, add a person or whatsoever, right? Then you can do what? Then you can use these matrices to do the adding and the subtracting. The other thing, let me take a simple example. A simple example will be that, let's say you have students, right? And you want to do their marks, like in a high school, you want to do their marks for term 1, term 2, term 3, test 1, test 2, test 3, and whatsoever. You put them in a form of an Excel. And let's say you want to change maybe element 5. You then do what you call matrix multiplication. Let's say all of them in test 3, they failed, and you want to give them 10 marks. Then you do what you call matrix multiplication. So that is why matrices are very important. So now in this section, we then look at matrix operations. So the outcomes at the end of this learning unit, you should be able to add and subtract matrices, multiply scalars with matrices, multiply matrices with scalars. So let's look at that. Now they're saying adding and subtracting of matrices. In order to add or subtract matrices, the matrices under consideration must be of the same order, meaning that if A is a 3 by 3 matrix, B has to be a 3 by 3 matrix. If A is a 2 by 1 matrix, B has to be a 2 by 2 matrix, 2 by 1 matrix as well, so that you can be able to do what? You can be able to do matrix addition and subtraction. Are we all together there?
Yes, ma'am.
Yes. So this is the whole statement basically of what I said. A and B has to be the same order. Now, for example, example 1 says, find the sum of these two. Obviously, when they say find the sum, they want you to add, find the difference, they want you to subtract. Now, before you actually find the sum, let's see the order of these matrices. The first matrix is 1, 2, 3. So that's 3 rows and how many columns? 1, 2, 3, 4. So meaning this matrix is a 3 by 4 matrix. Let's see this one, 1, 2, 3, 1, 2, 3, 4. This is also a 3 by 4 matrix. Now, how do you add these matrices? So for you to add these matrices, let's say this is a plus here. We're saying this matrix plus this matrix. You go element by element. And now when you are adding, we know this is a 3 by 4 matrix. And this is a 3 by 4 matrix, meaning that the answer will also be a 3 by 4 matrix. Are we all together? Are we all together, yes or no? Did I miss anyone?
Yes, ma'am.
Okay,
together.
so then you go and say 3 plus 2, that's 5. 5 plus 0, that's, sorry. Okay, let me start afresh here. So 3 plus 2, that is 5. 5 plus 0, that is 5. 0 plus, 7 plus 7, that is 14. 4 plus 2, that is 6. 4 plus 1, that is 5. 6 plus 0, that is 6. 1 plus 8, that is 9. 3 plus 3, that is 6. 2 plus 7, that is 9. 9, 0 plus 1, that is 1. 4 plus 1, that is 5. 8 plus 6, that is 14. So then that's how you do your matrix addition. With subtraction as well, it's the same thing. You go element by element. Are we all together, guys?
Yes, ma'am.
Yes, ma'am.
So now let's look at this. Oh, find the difference. So now they say find the difference between this matrix and the matrix I. What do they want us to do? What is the matrix I?
Diagonal 1, they want us to subtract it from the first.
So you can't say it's a diagonal matrix. It's a what? Yes, it's a type of a diagonal matrix, but I means what? It's an which type of?
I said the one diagonals it's a square, also square matrix with one being in the diagonal.
Well done.
Ones.
So well done. So that's called an identity matrix. Right? Now,
Yes,
which one? What is the dimension of that matrix? That diagonal square matrix with one? The identity matrix. What? It will be what?
3.
A 3 by 3.
Well done. So it will be a 3 by 3. Reason being because they want us to subtract. And remember we said we can only subtract or add if both of the matrices have the same dimension. So meaning that this I, they didn't write the number. So meaning that this I has to be a 3 by 3 matrix because we have 1, 2, 3 and 1, 2, 3. So we have 3 rows and 3 columns. So for us to be able to add to that, we need an identity matrix with 3 rows and 3 columns. So that's 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the matrix we're subtracting from. So meaning that they want us to go and say, this is 2, 4, 4, 3, 6, 8, 5, 8, 1 minus 1, 0, 0, 0, 1, 0, 0, 0, 1. So then this is equals to, you then go 2 minus 1, that is 1, 3 minus 0, that is 3, 5 minus 0, that is 5, 4 minus 0, that is 4, 6 minus 1, that is 5, 8 minus 0, that is 8, 4 minus 0, that is 4, 8 minus 0, that is 8, 1 minus 1, that is 0. And then that's how you subtract matrices. Are we all together there?
Yes, ma'am.
So now they say the same properties which apply to addition for real numbers also apply to the addition of matrices. Now we will state these properties here without proof. So meaning that you don't necessarily have to know the proofs for the exam. So what do they mean? They mean that the properties, you know that 2 plus, do you agree with me when I say 2 plus 4 is the same as 4 plus 2?
Yes, ma'am.
Good. So that is called the commutative law. And the commutative law, it's also applied to matrices. Meaning if you have matrix A plus B is the same as B plus A. Are we all together?
Yes, ma'am.
Yes, ma'am.
And you can see that the commutative law only applies for what? Addition and not subtraction. Because it makes sense. 2 minus 4 is not the same as 4 minus 2. So let's go to the next property. The next property it's called an associative law. We know that 2 plus 3 plus 4 is the same as 2 plus 3 plus 4. So meaning that if you have a matrix A plus B plus C is the same as A plus B plus C. That's called an associative law. We know that any number add by 0 is that number. So meaning that if we have 8 plus 0, we know that's the same as 0 plus 8, and we know that the answer is 8. So here they're saying that if you have a matrix A plus a 0 matrix, it's the same as the 0 matrix plus A, which is just the matrix A. Okay? I hope we are all together there.
Yes,
Yes,
ma'am.
ma'am.
Thank you. Now, so basically, guys, this is what you're going to need, especially if you're going to use your master's coding. If you're going to use coding, you normally use matrices. That's whether it's in computer science, whether it's in engineering, where you have to use MATLAB, or whether it's in applied mathematics, where you also have to use MATLABs. We do use a lot of matrices. So if you know these operations, then it becomes easier for you. So then you know that if I have 2 plus minus 2, I get 0. Same applies to matrices. That if you have matrix A plus the negative of matrix A, then that is equal to the 0 matrix or the null matrix. I hope all those properties are in the head, in the mind, and make sure you know them by heart, because you will not get them in the formula sheet. Now they say scalar multiplication. A scalar is a quantity with no direction associated with it. Example of a scalar are temperature and volume. The same definition used in physics for a scalar holds. They obey the usual rules of real numbers. Basically, that's what we're saying. 2 plus 4 is the same as 4 plus 2. Now, the product of a scalar, let's say P, we call it a scalar, right? In this case, with an n by n matrix is obtained by multiplying each element of A with the scalar P. Meaning that if P is the number, right? And you have a matrix A, let's say A is this. A11, A12, A21, A22. And we are told that P times A, meaning that you're going to go and say A11 times P, A12 times P, A21 times P, and A22 times P. Did I lose anyone there? That's the scalar multiplication with the matrix.
No, ma'am.
Thank you. So now here they say find 4 times a matrix, a 3 by 3 matrix. So meaning that this is 4 times 2, that's 8, 4 times 3, that's 12, 4 times 5, that's 20, 4 times 4, that's 16, 4 times 6, that's 24, 4 times 8, that's 32, 4 times 4, that's 16, 4 times 8, that's 32, and 4 times 1, that's 4. That's called scalar multiplication of matrices. I didn't lose anyone there, right?
We are with you.
Thank you. So now they say in general, the following holds for scalar multiplication. They say that if you have a scalar, here, the first one says if you have a scalar P, that's 2, 3, negative 1, 1, 7, and you multiply with matrix addition of while you're adding A and B. This is the same as A times B plus, P times A plus P times B. Same applies if you're adding 2 scalars, P and Q times A. This is the same as P, A plus Q, A. Even this one, P, where you have a scalar outside and you have A, which is, Q, which is a scalar multiplied by A. This is the same as first multiplying the 2 scalars and then multiply by the matrix A. I hope we are all together there. Did you guys do matrix multiplication in the previous year? Guys? Hello?
Hello,
Should I
ma'am.
assume you did it? Did you do matrix multiplication in first
I am
year?
doing Yeah, I think we did, ma'am. Let me
Oh,
check
okay.
something.
Okay. Do you remember it?
I'm not sure.
You have to remember it because the exam will be on matrix multiplication.
Oh, okay. Where you it's either you choose you multiply your rows or your columns, right? That's the one.
Yes, that's the one.
Oh, yeah.
So let's remind each other. So they say the product of matrices is only possible if the number of columns of the first matrix is equal to the number of columns or the number of rows of the second matrix. Now, if matrix A is of order M by Q is multiplied with matrix B of order K by N, a new matrix will be formed, which is order M times N is obtained. Now, let me summarize this. They say that if you have a matrix A, and you know that matrix A, order M, it has M rows times K columns. And you have matrix B, it has M rows times K columns, right? For you to be able to do matrix multiplication, this must hold. So if you're going to say A times B, meaning that we know A is an M by K and times B, which is a what? M by K, right? M by K matrix. For you to be able to do matrix multiplication, in this case, you can't because this is not equals to that. The two inner dimensions are not equal, meaning that this, for matrix multiplication to hold, this must be a K, because this is K, this must be a K by something, let's say K by N. So this and this, the inner dimensions, they have to hold. Are we all together?
Yes, ma'am.
Yes, ma'am.
So meaning that if I have A, M by K, and I have B, K by N, I can find A times B, but I cannot find B times A. Do you see that? And do you see why? Guys? Do you see that and do you see why? If you don't see why, you shout.
Yes. No, ma'am.
Okay.
I don't see why.
Okay. So A times B, right? Let's put the dimension next to it. We know this is M times K times B is K times N. The inner dimension, this is the same as that one, the inner dimension. But for B times A, B, we know this is K times N times A, which is M times K. Now this is N, this is M. So those inner dimensions are not the same, and therefore you can't do matrix multiplication.
Okay, ma'am.
Sure. Now let's do this matrix multiplication. Before we do this matrix multiplication, let's go and check the dimensions. It's very important that we check the dimension with the screenshot. I want you screenshots. So let's do the screenshot here. Okay. Give me a sec, please. Second. With the screenshot new. I want the screenshot over here so that we can do that matrix multiplication. Isn't that we are reminding each other, so that since we are reminding each other, we need to go step by step. See? To reduce the size. There we go. Now, they want us to find matrix, this matrix that we don't know. Okay, no, we know it, but they didn't label it. Let's label this A. Okay. Let's label this matrix A. Okay, my pen is no longer writing, guys. I do not know why. Okay, give me a second. I think it's a battery. Let me see if I can change the battery. Oh, okay, it's writing. So let's label this matrix A. And let's label this matrix B. Look at this, matrix A. What is the dimension of matrix A?
2 by 3.
2 by 3. What is the dimension of matrix B?
3 by 4.
3 by 4. Do you see that? Because we're looking for A times B. The inner orders are the same.
Yes, ma'am.
So since the inner orders are the same, therefore we are allowed to do matrix multiplication. Now the answer is C, right? Now the answer is C. And the answer will be, look at this, will be a 2 by 4 matrix. Did you see how I found the dimension for C? Done. So now, since we know C will be a 2 by 4 matrix, meaning that C will have 2 rows and 4 columns. So it will be 1, 2, and 1, 2, 3, 4. So meaning that we'll have C11, C12, C13, C14. Then we'll have C22, C21, C22, C23, and C34.
C24, ma'am, not 34, 24.
Thank you. 2, 4. Hey, yeah. Thank you very much. Okay, so now let's look at this. How do we do matrix multiplication? This is how we do matrix multiplication. Let's remind each other. We'll say row 1, column 1. You see the C11 here. It means row 1, column 1. C11 means go and fetch row 1. Where's row 1? It's this one in the first matrix, and column 1 in the second matrix. You remember that one now?
Yes, ma'am.
So meaning that they want you to fetch row 1, which is 2, 3, minus 1, and then column 1, which is negative 1, 0, 2. Are we all together?
Yes, ma'am.
Now,
Yes, ma'am.
how do we find it? Okay, let me write it like this. It's important because now it's important that you're able to do this multiplication nicely, because these are easy marks in the exam, and I want you to get total in them so that you can get your distinctions. Now, when you do matrix multiplication, C11, you go take row 1, column 1. We took it. Now, let's do multiplication. You then say 2 times negative 1, 2 times negative 1, plus 3 times 0, 3 times 0, plus negative 1 times 2. So what is the answer there?
Minus 4.
4. Meaning that in the position of C11, we put minus 4. Can someone tell me C12, what am I going to take?
Row 1, column 2.
Row 1, which is 2, 3, negative 1. Column 2, which is 0, 1, 5. So how do I multiply? I'll say
2 multiplied by 0.
2 multiplied by 0.
Plus 3 multiplied by 1.
Plus
Minus 1 multiplied by 5.
Well done. Which gives us what?
Minus 2.
Minus 2.
Minus 2. C12 is in this position. Then let's go to C13, quick. C13 is equals to?
Oh, 2, 1, 3, 2, 3 minus 1 multiplied by.
So it's row 1 multiplied by
Column
3.
3.
Well done. So that's 2, 3 minus 1, negative 2, 6, and 4, which is equals to, help me there.
Do you need the answer only, or do you need?
No, I want
everything,
all
the steps?
Yes, I want, for
2
this one, I want all
multiplied
the
by
steps.
minus 2.
Well done. Yes.
Plus 3 multiplied by 6. Plus minus 1 multiplied by 4.
The answer is
10. 10.
Okay, let's move quicker now. 1, 4. So we're taking which row?
Row 4, row 1, column 4.
Thank you, column 4. So row 1, we know row 1 is 2, 3 minus 1. We don't know column 4. Let's go and see it. It's 1, 2, 3. So it's 1, 2, 3. So we know that this is 2 times 1 plus 3
Plus
times
3
2
times
plus negative 1 times 3. The answer is equals to
5.
5. Then we know this is the last part here. Now we come here. We are done with the top part. We come here. C21. What is C21? C21
2,
is,
column 1.
thank you, row 2, column 1.
1.
So what is row 2? Row 2 is 0, 5 negative. Thank you. And negative 1.
Minus 1.
Thank you. So then we go and say 0 times negative 1.
Plus 5 times 0.
Plus
Plus minus 3 times 2.
which is equals to
-6.
6. So then we come here and put -6. Which one is the next one? C22.
Row 2, column 2.
Well done. What is our column 2? Erase
And-
row 2, column 2, 0, 1, 5. So that's 0, 1, 5, which is equals to?
0 multiplied by 0
Done.
plus 5 multiplied by 1
All done.
plus -3 multiplied by 5.
Which is equals to?
20.
20.
No, wait.
18.
No, it's not 20, ma'am.
It's
13.
what? 18.
-10.
Is it 13 or 20 or 18?
It's -10.
We are doing the right steps, but are we doing the are we giving the right answers -10? Okay.
Yes.
Next one.
Row
See?
2, column 3.
Thank you. Guys, I want you to give me row 2, column 3. I want you to
Okay.
get total in the last assignment. Total in the last assignment.
Okay, ma'am. 0, 5 -3.
Wait, I need negative
Minus
264.
264.
Negative 264. So this is equals to 0, -2 plus 5 times 6 plus -3 times 4 equals to
3 times 4. 18.
18. Then we have
Row 2,
C2.
column 4.
Thank you.
0, 5 -3.
So it's 1, 2, 3. So 1,
1,
2, 3. So this is equals to 0 times 1 plus 5
Yeah.
times 2
times
plus
times
-3 times 3.
3 times 3.
Which
1.
is equals to 1.
1.
Okay, then we go. So we are done with we are done.
Yes, ma'am.
Thank you. So that's how we found C. Now, did I remind you? Are we sorted now, right?
Yes, ma'am.
Thank you. Thank you. Let's go back. There we go. There we go. Where's our C? Oh. I'm only seeing 110 in yours. -4, -2, 10, 5, -6, -18. Where did we go wrong? Did we go wrong or did we go right in everything?
Check C13.
Okay, let's do this. Come back.
C13 is fine. There are 2 10s.
There, what?
Go back to the end and check your C13. You'll get 10, and then your C12 is also 10, I think. Your C22, yeah, C22.
I think we got 10s for both.
I think
But
I
the
think
other
we
one
are
is
right.
negative and the other one is positive.
Really?
Yeah, check.
yes.
Look at this. -4, -2, 10, 5. -6, -10, 18, 1. Let's go and see. -4, -10, 5. -6, negative. We are right. Are we not right?
You're right.
Yes, it's right, ma'am.
You're
Well
right,
done.
ma'am.
Let's move. Let's move on. Then you'll go and do this one. I want 100 in assignment 3.
Assignment 2
Okay.
showing us flame. You'll get 100, ma'am.
And I'm seeing flames in assignment 1 while marking, guys. So,
Assignment 2, partial integration is showing us flames. We don't know what's going on.
it means
We're
we need to
struggling
do
here.
something. We need to do something.
Yes, ma'am. We
Okay.
have to, like, when we're revising partial integration for partial integration, we should do it like it's showing us
Okay,
flame.
no problem. We'll talk after the class then. So now the following properties generally apply to the multiplication of matrices. They say, okay, now the reason why they put these small properties, it's because it's things that you will need. You will see as you start programming, guys. You will see. as you start going up, I mean, you have to use your Pythons, your C++, your MATLAB, your mathematicals, and dealing with matrices. You'll see these why the importance of these properties. Now they say that it's the same as if you have 2 times 1. You know, if you have 2 times 1 is 2. Same applies to identity. If you take a matrix A multiplied by the identity, is the same as multiplying the identity with A, which you get the matrix A. That's what they're saying. Now they're saying if you have A and you first multiply B and C, is the same as multiplying A and B first, then multiply by C, which gives you A, B, and C. This one says, I have A outside and I'm adding B plus C, then multiplying by A is the same as multiplying A by B plus A by C. Reason being, sometimes it's not easy to code this part. I know, I'm talking from experience. I'm using MATLAB and Mathematica. It's not easy to code this part with big matrices, but it's easier to do this, the left-hand side, this right-hand side. Same applies to this one where you add A plus B first, then multiply by C. This is the same as AC plus BC. Now they say if a square matrix, now remember that you can't find A to the power of something if that matrix is not a square matrix, right? So now they're saying that if a square matrix, if A is a square matrix, it is possible to multiply the matrix by itself, meaning you can find A squared, which is the same as A times A times A. You can find A to the power of 3, which is A
only
times
A times A only. A squared is A times A, not 3 A's, ma'am.
Yes, sorry, A times A. Thank you. So that's what they're saying. And I hope you put that in mind. So now here they're saying that, okay, fine. We want matrix. We have A, which is our 2, 4, 0, 3, and we want A squared. And we know that A squared is the same as A times A, so meaning that this is the same as 2, 4, 0, 3 times 2, 4, 0, 3. And because we did matrix multiplication, we can skip, and then we say this is 4, 20, 0, 9. Isn't that we are comfortable with matrix multiplication? We can go and check this one now. Yeah, bro. Unlike clear scalar multiplication, in matrix multiplication, the product of the two matrices can be equal. They say what? What are they saying here? Unlike the scalar multiplication, in matrix multiplication, the product of two matrices can equal to the null matrix without either of the two matrices being a null. Oh, so they're saying that, you know that if you have 2 times 0 in scalars, you know this will be 0, or any number multiplied by 0, that will be 0, right? That's what they're saying. But with matrices, you don't necessarily to have any 0 matrix. If you have A times B can be any matrix, which is not a 0 matrix. And at some point, they can give you a matrix, which is 0. In this case, they gave an example here. You see that this matrix A, which is a row matrix or a row vector, times this big matrix here. This matrix, which is a 3 by 3 matrix. Both of them are not 0, but when you multiply them, they give you a 0 vector. Now, let's remind ourselves. This is a so if we call this A, this is a what? This is a 1 by 3 matrix. A 1 by 3 matrix. And this is a 3 by 3 matrix. Let's call it B. Now the inner ones are set. What's this? The inner dimensions are okay, so we can do that matrix multiplication. Meaning the answer will be a 1 by 3 matrix. Okay. Let's see. Yes, it's a 1 by 3 matrix. Are we all together?
Yes, ma'am.
Thank you. They say some operations do not apply to matrices. Division of matrix is not defined. This means that if you have matrix A, X, and Y in the equation, this equation, therefore you cannot go and do, remember when you have 2x is equals to 2y, you were dividing by 2 and then you have x is equals to y. Do you remember that? Now they're saying that that doesn't apply to matrices. If you do that, you're not doing mathematics. So how do we fix such problems? Let's look at that. They say some operators do not apply to matrices. Division of matrices is not defined. This means that for all matrices A, X, and Y in the equation, this does not imply X is equals to Y by dividing A. So we can, however, find that X is equals to Y by multiplying with the inverse of A on both sides. If we are dealing with square matrices. So we will define the inverse of a matrix in the next learning unit. They say that because a matrix division is not satisfied, and because that if we have X is a matrix, A is a matrix, and Y is a matrix, because we can't divide by A, what we can do, we can get this by using what we call an inverse of a matrix. Why are we using an inverse of a matrix? Because according to those properties where an inverse of a matrix is involved, if we multiply by the inverse, this is how to the power of -1. And when we say to the power of -1 in matrices, you're saying you're finding the inverse of a matrix. So because if you multiply an inverse of a matrix like this with a matrix, you find what we call an identity. If a matrix is a 3 by 3, if you multiply the matrix and its inverse, you get a 3 by 3 identity. So what they're saying is, they're saying that if I go and multiply both sides, I say A inverse times A times X is equals to A inverse times A times Y. Then we know that this will form an identity. Then we know that this will be equals to the identity times X is equals to the identity times Y. And we know that there's a property that says if you take a matrix times by identity is the same as the identity times the matrix, which is just that matrix. Therefore, that's where we'll get the Y. Are we all together?
Yes, sir.
So it means that it is important to find the identity, the inverse then, if we want to solve such problems. Okay, let's do that. So those are post examples. Go do them. Please, guys, do them. Do them. Do them. Assignment 3 will be very easy. If you do all these exercises and understand them, you get your assignment 3 and you get your 15 marks in the exam of this part. 15, 10, I don't know. I'll decide.
Make it 15, ma'am, so that we don't fail too much.
We'll talk. Okay, so let's say inverses of matrices. Now let's get into inverse, because apparently this thing called inverse is very important. So why not to go into it? Let's see. Let's say at the end of this learning unit, you should be able to calculate the inverse of a matrix. Did you hear that?
Yes, sir.
So they say a matrix is called non-singular if another matrix exists such that the product of two matrices results in an identity. So meaning that they'll say A is a non-singular if there's a B such that when you multiply them, you get an identity. Then you say that matrix is non-singular. You'll come across the non-singular term as soon as you start working with matrices, as soon as you start working with real data at which you have to put it in the form of matrices. Now they say then you call B the inverse of a matrix A. So the inverse of a matrix, is only defined for a square matrix and is usually defined by this. And they're telling you that if you take the matrix A, multiply by the inverse of that matrix, then you get the identity. I almost said something you learned, but let's not go there when it comes to inverse properties and stuff. Or also, when you take the inverse, multiply by identity, you get that it's an identity. Therefore, if A is an n by n, then the inverse also has to be an n by n, the order of the inverse. Now, all square matrices do not necessarily have an inverse, meaning that if I can give you a question and say find the inverse, you need to know whether the inverse exists or it doesn't exist, because you'll waste your time trying to find the inverse. They're saying not all square matrices have inverses. But if an inverse does exist, it is unique. It is only one, and there are no many. A matrix, therefore, only has one inverse. The null matrix, for example, does not have an inverse. Make sense? Yes, no?
So
Any questions so far? Any questions so far?
No, ma'am.
Okay. So now they say we need the concept of minors and cofactors of a matrix and the determinant of a matrix to determine whether or not an inverse exists and to calculate the inverse of a matrix if it does exist. Do you see that? Meaning that you need to check if the inverse exists. It's like when you were checking functions, you were like, oh, vertical line test checks the what's this? It checks if the function exists. Then you go and say, oh, now you need to use the horizontal line test to check if the function is one-to-one. So same applies here. You're given a matrix, you don't assume the inverse exists. You need to just go check if the inverse exists. Once the inverse exists, then you do what? Then you find that particular inverse. Now what are they saying? You will be wise to revise your mathematics 1 notes. Did you guys revise your mathematics 1 notes?
We'll check, ma'am. We still have them.
Okay, I even uploaded them on additional resources. Now, the first step in calculation of an inverse of a matrix is to find the determinant of the matrix. If the determinant of a matrix is calculated and is equals to 0, such a matrix is called a singular matrix, and the inverse does not exist. Meaning that the question says, find the determinant of a matrix. Find the inverse of a matrix. You go find the determinant. If the determinant is equal to 0, then you tell them the inverse does not exist, therefore I cannot find it. Are we together in this?
Yes, ma'am.
Thank you. Determinants are only applicable to square matrices. The determinant of a matrix is denoted by / as if you're looking at the absolute value, but you're not looking at the absolute value of the x. Okay, they're not showing you how to find the determinant. Do you remember how to find the determinant?
Yeah. No, ma'am.
Okay, let's find the determinant for number 2 and let's find out the determinant for number 4. Because it looks like you did it, but you didn't remember it. Let's find the determinant for a 2x2 and let's find the determinant for a 3x3 matrix. I won't give you a 4x4 matrix in the exam unless I just want simple stuff such as transpose and whatever.
Okay, which determinant are we looking for?
For number 2. Let's start number
2.
Wait.
So number 2, we're gonna say
please wait. Let me do a screenshot here. Disclaimer, I just combined my students today. There's a reason why. Hey guys, can you hear me?
Yes, ma'am.
Pardon,
You
ma'am?
combined us. We are only 4 in class.
Yes. I combined you with some of my students from first year.
Oh, okay.
Yes. They need this as well. And I didn't send the link after. Me. Okay.
But you send out an email to Outlook, so they must check their emails. The link is there at Outlook.
Oh, I didn't send the first year. I called some of them.
Oh.
Yes. And Brenda is here, so I needed you guys to do this. In which module you are doing this matrices, Brenda?
MAT2691.
That's why I wanted you guys here. I do apologize. I didn't send the link for the class, but I'll send the recording so that you guys go through it for revision.
They'll hear me balabaling in this recording.
If you want to hear them balabali, those ones they balabale.
Like, ma'am, I talk too much. Like,
ma'am, please,
when I was at
send the
practicals,
link for our class.
They'll know me. Next time when I meet them at the practicals, they will say, this is Gefenza. You are my help. We heard you in Maths 2 talking.
You will be there. You will, because they are coming to the MAT2 as well. Some of them will be doing BSc modules. So you will be their mentor.
Ma'am, it's not
So when
that.
you do your masters, you'll be my tutor.
Ma'am, I'll
You
be
see?
doing it. I need money. I'm tired of being broke.
You see, so when you do masters, you'll be my tutor and you'll be their mentor. Hey, they balabal these ones, and they work, eh? I like the fact that they work. They work
Yeah,
very hard. I won't lie, they work very hard, those ones. Okay. Let's start with number 2. Okay, Brenda, I do apologize for not sending you guys the link for this class because this is my second year class. So what will happen is I will send this video and make sure to send it on your group as well. And we shall talk our dabas after for first year dabas. So let's call this A, and then we'll talk the second year dabas after. Okay, now -1, -1, 1. So the determinant of A.
It's 1 times 1. So we do the diagonal. So 1 times 1 minus.
So we say 1 times 1, this diagonal?
Yes. Minus the other diagonal times.
Thank you. The off diagonal. So we do the main diagonal, which is this one, and then we say minus this one. -1, -1. So this is equals to 1, -1, -1.
1.
Why are we getting 0?
It's 1. Are we supposed to add in the middle? Are we minusing or adding?
We are minusing.
Then it will
So this
be
is
0.
equals to 0. Now, you see this matrix. If I say find the determinant and you find the inverse of this matrix and you find the determinant is equals to 0, this is a singular matrix, meaning the inverse does not exist. Do you see that? The inverse does not exist. Remember, if the determinant of the matrix A, let's say it's A, B, C, D, then you say A times D, A times D minus C times B. That's the determinant of A times. Now, there are so many ways of finding the determinant of a matrix, a 3x3 matrix. There are 2 or 3 ways. But me, I'm comfortable with one, or I'm even comfortable with the second one. I think I'm just comfortable with finding the determinant. So for now, which one are we using? Let's use this one and you go look at the other one, because in your study guide, they used both of them. Right? So now let's look at B. So with B, we have -5, 8, -3, -6, -9, and 4. And then you have 7, 0, and 2. Right? So you can then also go and write the first 2 columns. So you can go and say -5, 8, -3, right? -6, -9, and 4. Are we all together?
Yes, ma'am.
Then you highlight, you start with the main diagonal, you highlight this one 1, you highlight this one 2, you highlight this one 3. Are we all together?
Yes, ma'am.
And then you highlight the off diagonals. Let's use purple. You highlight the off diagonal, which is this one. Ooh, no. It's highlighting my numbers. Okay, let's use, which one? Blue. You highlight this one, 1. You highlight this one, 2. And you highlight this one, 3. Are we all together there?
Yes, ma'am.
Now then you go and multiply the yellow ones. The first block is for the yellow ones. Subtract the second block is for the blue ones. Are we all together then? So then you go and say the first yellow line is -5 times -9 times what? Times 2. The second yellow plus -6 times 0 times -3. The last yellow line is plus 7 times 8 times -4. And then you quote minus the blue lines. The first blue line is 3 times -9 times 7 plus the second blue line, it's 4 times 0 times -5, plus the last blue line, it's 2 times 8 times -6. Are we all together there? Guys, what is the answer? What is the answer? Hello? What is the answer?
Still doing it, ma'am.
Problem.
So remember, what is this method called, the one that you used?
I apologize. I do apologize. I'm back. What did you get? Check how far we are with the study. Good. Yeah, according to finishing. What are you getting, guys?
Still doing. I'm almost done, ma'am. Just give me a few seconds now. I'll give you the answer now.
No problem.
I'm getting -195.
195.
Minus 195.
Why are you getting 195?
I wanna check if I did the correct things. Yeah. Is it 543? -5, 9, and 2, yes. 6, 0, and -3.
Let me check on my side. So this is -5, 9, and 2, -6, 0,
0, and
and
-3.
3, and then it's 7,
8,
8,
yes.
9,
And
7, 8, 4. This
7,
is
8,
4.
4.
Yes,
Is it?
7, 8, 4. My apologies.
Yeah,
This is 4.
4. Also, my apologies on my side. I saw my mistakes. Let me confirm the other two.
So this is
That's
4.
3,
And then the blue one is 3,
-9,
-7.
and 7, plus 4, 0,
And look at
and
the 3,
-5.
guys. Look at the mistakes are we doing. This is -3. Do you see that?
It's minus the
It's
first one.
minus.
It's
It's minus.
-3 here.
Minus
It's
3,
-3.
-9.
Thank you.
I
So
got
it's
one
minus.
minus 117.
Yeah, -3. Okay.
Okay. So let's fix that, guys. Let's fix it first. So it's -3, -9,
-9 and 7.
7. Yes.
And
Then
that's
we come
minus
to 4.
4. Is it minus or 4?
Just 4.
It is 4, right?
4,
4,
0.
0, and
0.
-5. Okay. And
The
then we
other
have
one,
2,
2, 8,
8,
and
and
-6.
-6. Okay, let's do that now. And remember, it's a minus here.
Not a positive. Let me check. I think I did
No.
a positive.
The blue one, the yellow one's minus the blue parts.
Oh, yeah, I did a positive here. I'm getting positive 221.
Well done. It's 221. I opened the study guide, so it's 221.
I saw my mistake. I did positive instead of a negative. I did addition instead of a subtraction. That's why I was getting that.
Yes. So make sure that it's the blue part minus the yellow part minus the blue part. Are we all together?
Yes, ma'am.
And I checked our determinant for that one was 0, so we were right. Okay. Now, minus and cofactors. So we are comfortable with what's this? We are comfortable with the things, right?
Determinants.
Sorry, ma'am. What
Yeah.
what is the formula that you use to this one?
So I didn't use the formula. What I did was I went to, you see this matrix here, number 4.
Yes.
And then I wrote the first column the way it is, 5, 8, -3. And then I went and wrote the second column the way it is, -6, -9, and 4. Do you see that?
Yes, ma'am.
And then I went to the main diagonal, the first main diagonal, and then I drew lines. Where's my thing? Do you see that? These lines, 1, 2, 3, the yellow lines. You first draw those lines. Let's do them. So this is the main diagonal. This is 1. This is the second one. And this is the third one. Do you see that?
Yes, ma'am.
So this is the green part. So then I said -5 times -9 times what?
2
Times 2 plus
minus 6 times 0 times -3 plus 7 times 8 times 4.
Then I was done with that one. And then I went, now I said the other diagonal direction. So which is these colors over here, the blue part. So then I went, where's the diagonal? It's this one. So I went like this. I went like that. And then I went like that. So you need to make sure you try to draw it according to scale so that you don't make mistakes. Do you see that? And then I said minus
3
so minus 3
minus
times
3 minus 9
minus 9 times 7 plus
7 4 times 0
yes,
times -5
well done, plus
2 8 and -6.
and then I calculated. Then in here I get an answer. Let's call it A, and then I minus the answer in B, and then we got 2, 1. Make sense?
Yes, ma'am.
Thank you. So now minus and cofactors. Remember, we haven't found the identity matrix, isn't it? So what we're doing is we are going and finding the piece of the pieces to find the identity matrix. Now they say to determine the inverse of a matrix, not the identity, I mean the inverse of a matrix, yes. To determine the inverse of a matrix, the cofactor matrix C must first be determined. The cofactor matrix C of a matrix A is the square matrix of the same order as A, where the elements Aij is substituted by its cofactor Cij. Does it make sense?
Well, ma'am, before we continue, is it a must that I find the determinants, the minus, and the cofactors before I get the inverse, or I just find one of the 3, and then if I get it, I can go to the inverse? Or should I get them, all of them, the determinants,
Let's learn what are minors and cofactors, because I might ask you find the cofactor matrix. You don't know. Let's learn them first and then answer the question. So they're saying if I have a matrix A, A11, A12, A21, A22, then the cofactor matrix of A is taking, it will be same dimension. If this is a 2 by 2, this has to be a 2 by 2, but it will be C11, C12, C22, and C21 and C22. Now, how do I so now they say this is called a cofactor of A11. This is called the cofactor of A12. This is called the cofactor of A21. And this is called the cofactor of A22. Now, how do I find those cofactors? To find the cofactors, those C11, C12, C22, C2 what? Hey, math is nice, guys. How do I find those cofactors? I then use this formula over here. Are you all together?
Mm.
Now, this is known as the minor of the element Aij, obtained by deleting row I and column I of the matrix, determining the determinant of the matrix that remains. Do you see that you still need to know the determinant just to find the cofactors even? Good. Now, they say that the factor, this one, meaning this part here, the first part here, right? That first part there is connected to the position of the element in the determinant. If the sum of the row and column is even, you know that -1 to the power of 2 and -1 to the power of 3, even will give us a positive 1. Odd will give us what? A negative 1. Yes. So now, here they gave you even a simple thing of saying you can just go find the minors of them, meaning find these ones and use these two boxes. Because I know in a 2 by 2, row 1, column 1, 1 plus 1 is equals to 2. Therefore, row 1, column 1, 1 plus 1 is equals to 2. Therefore, it equals to 1. That's why they say it's positive, meaning this factor here. This factor here. The second one is row 1, column 2. And 1 plus 2 is 3, which makes it odd. That's why they put it negative. Here it's row 2, column 1. 2 plus 1 is to the power of 3. Then -1 to the power of 3 becomes negative. That's why they put a negative. That's why they put it positive. Do you see how they find those positive and negatives?
No, ma'am. Can you go back from getting the positive and the negative?
Okay, let's start there. So they are saying that our elements, right? So this is equals to this here. This is the cofactor. Do you remember the cofactor of a matrix is, right? Now, they say instead of going and using this entire formula here, you can just find the MIJs and then multiply with the signs in here. Because we know that if -1 to the power of an even number, we know it will give what? It will give us positive 1. And -1 to the power of an odd number, you know it will give us what? Negative 1. You see that? And because the I and the J are the rows and columns when you add them, let's look at the 2 by 2 matrix. We know the first part is row 1, column 1. That is, this part here will be equals to 1 plus 1. And 1 plus 1 is what? It's 2. So 2 to the power, -1 to the power of 2 is positive 1. That it means here it will be positive here. The second one is row 1, column 2.
Okay.
And then we know it's row 1 plus column 2, which is equals to negative to the power of 3, which is -1. That's why they're negative there. Same applies here. 2, column 1, that's 2 plus 1, which is power of 3. That's negative. And here that's positive.
Which is 4. 2 plus 2, yes, ma'am.
Do you see? So here they even did the same thing for 3. So they are saying to you, you can either just find the minors and use this block to find the cofactor. We'll do that example later on. And we'll do both of them. So let's go. Okay? Now, here they say, consider the matrix, this one. Right? You see that, guys? This matrix, they gave you a matrix here. Okay? Now they want you to find the minor of 2, meaning the minor of 2. What is the position of 2?
First row, first column.
So it's 1, and 1, right? So the minor of 2, how do you get it? You cancel the first row, you cancel the
second column.
the first
The
column.
first column.
Then you
Sorry.
get the minor M11, which is equals to 6, 7, 2, and 4,
2 and 4.
which is this M here. Does it make sense?
Okay, yes, ma'am.
Now
Yes, ma'am.
to find C1, you find that, okay, let's not do that. Let's do minus first. Okay. Now they want you to find the minor of 7. Where's 7? Tell me where's 7 first. It's in the position of 7.
Second column, third row.
Remember, the dimensions are remote control. Dimensions are what? Remote control.
Remote control.
Meaning that
row
you
and
start
column.
with the rows, then you
Row.
come with the columns.
Yes, in the second row, third column.
Yes. Remember, we are not drunk uncles to call the remote control a control remote. It's a remote control. So
why do you give you more or less the same, baby?
it won't give you the same, because if you call for someone, you wanted to say third column and second row. So someone will think third column, which is someone will go say this one and this one. Do you see that? So with matrices, it's always a remote control. Sober uncle, remote control. So what is our remote for number 7?
2.
Control
3.
2. Well done. So meaning that for you to find the minor of 7, you have to say cancel row 2, the whole row 2, and cancel column 3. Then your M23 will be equals to the determinant of 2, 4.
1, 2. 1, 2.
Are we together?
Yes, ma'am.
Yes, ma'am.
Yes,
I
ma'am.
wanted to, this question is long. This question is long in the exam, so it has more marks and I want all of them. Alice, we are here to pass. Now, we know the determinant, right? It's this one times that, subtract this one times that. That's what they got. It's this one times that, subtract that one times that. That's what they got. Are we all together?
Yes, ma'am.
Yes, ma'am.
Now they say find the cofactor matrix of this one. What do they mean by finding a cofactor matrix? They mean that I have this matrix A, which is 4, 5, -2, and 3. I want to find the matrix C, which is C11, C12, C21, C22, where I use this to find it. Are we all together?
Yes, ma'am.
Yes. Okay. So let's take a screenshot here so that we have space. So that you don't get confused in when you're studying your study guide. When you're going through the work of your study guide, you don't get confused. Let's start with what they have. Okay. I have that matrix there. This is the matrix I have. And I have it there. And they want us to find the cofactor matrix, meaning that we have A, which is 4, 5, -2, and 3. And I want to find C, right? Now, do you remember that table of plus and minus?
Yes, ma'am.
Okay, let's write it here. What it was? It was plus,
minus, minus, and plus.
And plus. So this is how they found it in your study guide. In some questions, and in some questions, then they use the other one. You see?
The 3 by 3 one.
Yes. So now here, because you know this table, you can use this one. Let's call it method 1. Because you know that one, you can go and find minus. Do you see that? Because we know that Cij is equals to -1 I plus j Mij. And we know this one has already been covered here. So we just need minus. So minus is M11. We're looking for M11. Where are we cancelling? We're cancelling the first row and the first column. So we left with what?
3.
Left with 3.
Hmm.
And then now, because remember, we want C11, C12, C21, C22. And 3, it's C12. C12 will be negative because 1 plus, okay, let's not focus on that, but we know it will be here in that position. So C12, we cancel which row?
Negative.
Which cancel which row?
The second one, ma'am.
We cancel which row? Cancel which rows and which columns?
We cancel row 1 and
Yes.
column 2.
Thank you. So the answer is what?
-2.
Then we come here. This is the M's are called the minus. 2, 1. We cancel which one and which one?
Row 2, column 1, which is 3. 5.
And then M22.
Row 2, column 2.
We left with
4.
Well done. Now the C, which is a cofactor matrix of A, you now go and say the first part is positive, isn't it?
Mm.
So it will be 3. The second part, do you see it's negative?
Yes.
Negative times negative gives you what?
+2.
The third part is negative times this 5 gives you?
-5.
And this one times that one gives you positive
4.
That's the cofactor matrix of A.
Mm.
It was easy, ne? Should I give you 2 seconds to absorb it? Should I give you 2 seconds to absorb
like
it?
finding the determinant using that I don't know what do they name it, where you are like A1, then you put like you remove the row and the column, then you're left with the 4. So it's same thing, but you're just doing it on a 2 by 2.
Yes. So minus are determinants of cancellation.
Okay.
You will see that in 3 by 3. These M1, M2 are actually determinants of 2 by 2s. If you're looking at a 3 by 3. I think if it will be a 4 by 4, there will be a determinant. For example, let's say you have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. This is a 4 by 4, right?
Mm.
Now, if you're going to find a what's this? A cofactor of A, right? A is in position 1. It's in row 1, column 1. So you cancel row 1 and column 1. Then your M11 will be the determinant of F, G, H, J, K, L, N, O, P. It will be the determinant of a 3 by 3. Do you see that?
Yes, ma'am.
So if it is if this was a 3 by 3, it means that these MIs will be the determinant of a 2 by 2. Are we all in this together?
Yes, ma'am.
Together, ma'am.
Now we need to go and check if we are right. We can be doing things. Maths is nice. Sometimes you do and you are smiling and it's wrong. What you are doing is wrong. Well, it's nice that you can check somewhere. Do you see that? This is what they did. And this is what we got. They found the minors only. And then they use the grid, the sign grid. And then they use that. Right? Now, my advice is if you know you're not like me who panics in the exam, because of time or whatever. You know you are right. You can use the grid. Eh? But if you know that, hey, You do make mistakes. Use the formula. Are we all together there?
Yes, ma'am.
Does it make sense what
Yes,
I mean?
ma'am.
Or
Yes,
should I
ma'am.
explain what I mean? What I mean is go and do C11 is equals to -1, 1 plus 1, M11. And you know that this is to the power of 2, so it becomes positive. M11 is what we, then you go and say 3. Then you get your answer. Then you go C12 equals to -1, 1 plus 2, M12 is equals to, this is negative, a negative, M12, then you got that's -2, which is equals to 2. Then you go C13 is equals to -1, 1 plus 3, M13 is equals to, you know that it become positive 1 times M13. What do we get? Oh, there's no M13, there's M21. Which you got is 5. This is positive 5. Then C22 is equals to, what am I saying, guys? So this is 2 plus 1. This is -1, so this is -5. And then this is 2, so it's -1, 2 plus 2, 2, 2. This is 2, 1. So this is equals to positive. So this is positive 1 times 4, which is equals to 4. Do you see I didn't use the grid? You can do that. Are we all together in this?
Yes, ma'am.
Thank you very much. I come back. So let's do the adjoint of a matrix. Now the adjoint of a matrix is the transpose of a cofactor matrix. Please give me the adjoint of matrix A? The one we calculated? So meaning that the row 3, fix that one.
3 minus 5. 2, 4.
Thank you. So meaning that the rows becomes the columns, the rows becomes the columns. So this is called the adjoint of matrix A. This is called the cofactor of matrix A. Once you transpose the cofactor of matrix A, you get what you call the adjoint of matrix A. Are we all together in this? So they say the adjoint of matrix A is the transpose of the cofactor matrix. Now, question 3, example 3, they want us to find the adjoint of matrix A. And lucky for us, we know it. It's this one, because this matrix is what we calculated here. This is exactly the same as this one. So meaning we know the cofactor matrix of A. So cofactor matrix of A. Let's call it C. We found that it's this one, 3, 2, -5, and 4. Now the adjoint, it's the transpose C to the power of T. The transpose, so rows becomes columns, and columns becomes rows. So that's the adjoint. Voila. And listen to this. The inverse of a square matrix is given by the determinant. The adjoint divided by the determinant. So it means we know how to find the inverse now, right? Guys? It means we
Yes,
know how
ma'am.
to find the inverse. Because they say
Yes.
that adjoint over the inverse. In other slides or textbook, they write it like this: 1 over A times the adjoint, which is just the same thing of A. Note, the inverse defined only if the determinant is not equals to 0.
Mm-hmm.
Yes. Now look at this. They want us to find the inverse of A. We know that the determinant of A is equals to 4 times 3 minus 5 times -2. This is equals to 12. 12 plus what? Plus 10 is equals to 22. Now we know the adjoint. We did find the adjoint, which is this one over here. So the adjoint is what? Is 3 minus 5, 2, and 4, meaning that the inverse, A inverse, is equals to 1 over 22 times 3 minus 4 to 4. Like this. And you can always simplify that. This is equals to 3 over 22 minus 5 over 22, 1 over 11, and 2 over 11. So that's the inverse. Now, how do you check this is the inverse? You take this over here. You say, okay, fine. A, the inverse times A should give you an identity. Meaning that if you take 1 over 22, let's take while it still has that 22 minus 5, 2, and 4. If you multiply it with the matrix A, this one over here, 4, 5, negative 2, and 3, this should give you a 2 by 2 identity, which is equals to 1001. That's how you check if your inverse is correct. Are we all together?
Okay, yes, ma'am.
And that's how they checked. So they found it, which is this, the inverse, and they found this one here. Example 5. Let's look at example 5. Do you want to try it on the side? Let me see in the study guide how many questions we left with. Do you want to try it first on the side?
Yes, ma'am.
Yes, ma'am.
Okay. Please wait before you try it. Ne? Before you try it, I want us to do the last section because it's a bit long. Isn't that you know the steps, the adjoint, the what, you understand that part, right? Finding the inverse. Guys,
Ma'am.
you did understand finding the inverse, right? Of a matrix, you need the cofactor, then you find the adjoint, then you need the determinant. You understood that part?
The process,
Yes,
yes.
ma'am.
Okay, so now I'm going to skip because I don't want you to see the solution. The solution. Now they're saying, okay, fine. Remember when you were solving in grade? Let's talk about grade 10 because it was more simpler. You were solving simultaneous equation. Do you remember that one?
Yes, ma'am.
There you were solving simultaneous equations. You were actually finding that where the two graphs are intersecting. Now you were solving for x and y at the same time, right? And that was called a linear system of equation. In grade 10, it's a linear system of equation. Now they say that instead of saying let what be equation 1, subtract equation 2 from equation 3, you can use matrices instead. Go and try it. Only grade 12 work because 11 and 12, they introduce x squared there. So meaning that you can now use the what? You can use these matrices. Does it make sense?
Mm-hmm.
Yes, ma'am.
So now they say a system of linear equations. The reason why you need this system of linear equations, because sometimes you might be testing someone who is sick, you might be testing for their acidity of what something. I'm not a medical doctor, but you might test the heart rate, the BP, the sugar, the what, all those variables. Imagine testing 10 million people and you want to take all that data in one, like a matrix. You want to simplify the data, so you use a matrix. Now this says at the end of this learning unit, you should be able to solve the systems of linear equation using the inverse of the coefficient matrix. Did you hear that?
Yes.
Yes, ma'am.
Systems of linear equation. In mathematics 1, you obtain the solution of a system of linear equations with the aid of Cramer's rule. In this learning unit, the systems of equation of linear equation is discussed by writing a system in a matrix form and using the inverse of the coefficient matrix to find the solution. Now, they said a system of M linear equation with n unknown is set out as follows. Do you see this one? This is a system of equations. I'm using the wrong pen. This is a system of equations. And you can rewrite them. This is equation 1, equation 2, equation 3, up to equation m. Now you can rewrite them as a single matrix equation. And this is how you write it. Do you see that, guys?
Mm.
Okay?
Yes, ma'am.
So all these are constants. All these are x1, x2 that we are looking for. All these are coefficient. These ones are coefficient of
Okay,
x1.
mute, please.
Yes, please mute.
Because that
The coefficients of x1s, all of these are coefficients of x1s, coefficients of x2s, coefficients of x3s in the system. So that's the matrix A are these coefficients, x is what we're looking for, and B are the constant that you're given. So here A is known as a coefficient matrix of the system of a linear equation. Now, if the determinant of A is not equals to 0, the inverse A exists, and it allows us to solve this problem over here. Right? And how do we solve that problem? We go and find the inverse. After finding the inverse, we multiply both sides by the inverse. And then on the left-hand side, we know that A times its inverse gives us an identity. An identity times the matrix A gives us X, meaning that we can solve for X using this over here. Are we all together?
Yes, ma'am.
Thank you. Now they say solve the system of linear equation. So let's solve the system of linear equation. Let me take a screenshot. Where's my screenshot? There we go. And copy. Where's my world? There's my world. In my Word document. My geography teacher used to say world, in this world. This world. Okay. Now we're solving the system of linear equation, right? Now we want to write it in terms of ax is equals to b, right? Now there's one thing. If you're let's say it's written x1 plus x2 plus 2 is equals to 0, right? You write it in a standard form. All constants should be on the right-hand side. Are we all together? Do you see that, guys?
Yes, ma'am.
Thank you. All constants should be on the right-hand side. So now let's do this. So we want to write it. So we then go and say, what is our A? We know our X will be X1 and X2. We know our B in this case will be 1 and 3. So our A in this case will be the coefficient. Remember, we said this part is the coefficient of X1. These are coefficient of X1. These are coefficient of X2. So this will be 1, 1. And this will be 1, 2.
Yes.
Now,
Yes, ma'am.
they say to solve this. Remember, they said to solve this, we have AX bar. AX is equals to B. And we want to find the inverse such that when we multiply both sides by the inverse, this thing disappears. And we get left with X and then A inverse B. So meaning that we need to go and find the inverse of A. Now, to find the inverse of A, what's the first step?
Find the determinant.
Find determinant.
So let's call it determinant of A. In this case, they write it like this in our study guide. So then let's do that. 1, 1, 1, 2. So this is equals to 2 times 1 minus 1 times 1, which is equals to
1.
1.
1.
Does the determinant exist?
Yes, ma'am.
Thank you. Meaning that does the inverse, not the determinant, does the inverse exist?
Yes.
Yes,
Because
ma'am.
the determinant is not equals to 0. Thank you. So now, what else do we need? Second step to find the inverse. What do we need?
Cofactor.
Thank you. So we need the cofactor matrix. What is the dimension of a cofactor matrix? Let's call it C. Ruby?
2 by 2.
C11, C12.
Thank you. So it will be A, C11, C12, C21, and C22. Let's do that. So C11 is equals to negative 1, 1 plus 1, M11 is equals to, let's see. This one, C11 is positive, isn't it? So it's positive 1 times M11. We cancel which row, which column?
First row, first column.
Thank you. So we left with?
2, positive 2.
Thank you. Positive 2. So then this is equals to 2. So meaning here it's equals to 2. C12.
First row, second
Yes.
column.
First row, second column. Then we left with
1.
1. So the answer here will be what? Negative 1. 1 plus 2. M12 is equals to, we know this will give us negative 1. And this is 1. So this will be negative 1. Okay. Then C what?
Second row, first column. C21.
Thank you. 2 plus 1. M21 is equals to, this also becomes what? Negative. Negative 1 times M1. M21, what is M21? We cancel which row?
Second row, first column. Second,
then we
left, first column. 1.
What we left with, thank you. This is also negative 1. Then C22.
It will be positive 1.
Thank you, positive 1. Then
Second column, second row, and second column.
So we left with
1, which is positive.
So then this is negative 1, and positive 1. Then what do we do with our cofactor? Number 3, what do we do with our cofactor? Because we're looking for the inverse.
We do the adjoint. Adjoint or something.
Yes, let's do the adjoint. Well done. We're doing the adjoint now. So let's do the adjoint. As long as you know how to do the adjoint, that's what matters. So we're looking for the adjoint.
Adjoint.
And this pen. Adjoint. And how do you find the adjoint? I don't know what's wrong with my pen. So the adjoint of A, right, is equals to what? The adjoint of A is equals to?
The cofactor divided by the determinant.
Can someone remind me? The cofactor divided by determinant. Adjoint of A.
Our rows will become our columns.
Oh, that's the inverse. Yeah, sorry.
Thank you. C transpose is equals to, our rows becomes the column. So this, it's 2 minus 1, and this is minus 1. Hey, is it me or this matrix is symmetric? Do you see that?
Yes, ma'am.
Our cofactor matrix is symmetric. Then number 4, what do we do?
Then we use the formula that says A is equals to the adjoint.
The inverse of A is equals to 1 over the determinant of A times the adjoint.
Adjoint, yes, ma'am.
Of A. Well done. So then this is equals to 1 over the determinant of ours was what? Was 1. 1 times the adjoint, which is this one. So it's 2, negative 1, negative 1, 1. So this is 1 times the matrix 2, negative 1, negative 1, and 1. So this is equals to 2, negative 1, negative 1, and 1. Do you see that? Now, we were not looking for the inverse of a matrix. The question said solve the system. So meaning that we're going to say x, in our case, x is x1 and x2 will be equals to the inverse of A. In this case, it's a 2 by 2 matrix times B, which is a what? a 2 by 1 matrix. Can someone tell me, is matrix multiplication satisfied here?
Yes, ma'am.
Why?
The inside values are the same, the 2 and the 2.
Thank
The
you. The
inner
inside dimensions are the same.
Yeah.
So the answer would be what? What's the dimension of the answer?
2 by 1.
Thank you. 2 by 1. So meaning that it will be 2 rows and 1 column. So it will be like a column vector. All right. Now, that's what we are expecting. You see, math is nice. You know what you're expecting, but you don't know what you're expecting. So let's do this part. We know our inverse is what? It's 2, 1, negative 1,
And
negative 1, and 1.
Mm.
What is B?
1 and
3.
1 and 3.
1 and 3. Guys, remember I said, if this value, I'm saying this because some of you, I know you will write it wrong. X1 plus 2x2 minus 3 is equals to 0. If the system comes like this, fix it and write x1 plus 2x2 is equals to 3. I'm plucking you. I'm plucking you. My first years, they know what I mean when I say I'm plucking you. Okay?
Yes, ma'am.
So now, let's go and multiply. Let's do the matrix multiplication. So we know that here it will be what? Let's call it x1. This will be x what? X 1, 1 and x 1, 2. So x 1, 1 is equals to row 1, column 1. So that's 2, negative 1, then 1 and 3. So this will be equals to 1 times 2 plus negative 1 times 3. So what's the answer there? What's the answer? So this is 2 minus 3.
Minus 1.
Minus 1.
Minus 1. I'm writing with my finger, guys. Don't be surprised. I don't know why the pen is doing what it's doing today. Minus 1. And then the next one? The next one, it's what? Row, because it's x1, 2, so it's row 1, column 2. So row, no, this one is x2, 1. You're
Row
not
2,
correct.
ma'am.
Thank you. So this is x2, 1. This one here is x2, 1, right? So meaning it's row 2, column 1. So that will be, yeah, writing with the fingers.
Minus 1.
So it's x2, 1. This will be equals
1.
to 2, negative 1
times minus 1.
1, and 1
Plus.
and 3. So this is, well done, 1 times minus 1 plus 1
Plus
times
1
3,
times 3.
which is
Which
equals
is equals to 2.
which is equals to 2. So meaning that the answer here is equals to what? Minus 1 and 2. Meaning
Yes,
that
ma'am.
our B is equals to minus 1 and 2. Let's go and check. Let's go and check. While I'm fixing my pen, we need to go and check. Let's go and check. Let's go and check. Let's go and check. Well done to us. Then you
Bingo.
tell them that you know maths. You know maths, and then you say, therefore, x1 is equals to negative 1, x2 is equals to 2. There we go. Now, you have 2 questions. I'm stopping the recording because I'm going to give you time to go and then we do them together while I'm fixing the pen. Is that all right?
Yes, ma'am.
Yes, sir.
Thank you.